You want to get started?
Yep.
Okay, welcome everyone to Inspect the Unexpected, the impact of machine vision on inspection. I'd like to introduce our speaker today, Jonathan Hackney. Jonathan is an experienced senior sales application engineer at Computar, CBC America, with a demonstrated history of working in the industrial automation industry. He has a Bachelor of Science from Texas Tech University, where he studied industrial engineering. Just a little bit about Computar. For more than 40 years, Computar Optics has been a worldwide leader in developing innovative lenses. With their technological expertise, they consistently engineer superior optics and custom lenses. Okay, let's get started.
All right. Thank you, Dina. Hi, I'm Jonathan, and I'll be your host today. So here's an overview of what we're going to talk about today. And first, we're going to get through the introduction. We're going to talk about machine vision technology basics. Then we're going to dive into industry impact for manufacturing, healthcare, transportation, agriculture, and then a little bit more future impact of machine vision and AI. We'll talk about sustainability and energy efficiency, quality control, and robotics, AI, economic savings for future impact. And then for the next topic, the last topic, we'll talk about optics, technology, and the importance of lens selection. So that's going to be kind of our agenda today. And starting off, we want to basically address a few key questions. And so the first one here, and these are for the importance of how machine vision has transformed automated inspection. And so some of the questions that we bring up are, how has machine vision transformed that automated inspection, and how do the technological advancements in machine vision significantly impact the efficiency and quality of inspections? So for the next slide, we're going to talk about machine vision basics, and we're going to go broad. So we're going to talk about manufacturing, machine basics, kind of all of it as a whole. And so when you're dealing with those systems, they're going to be typically these key components for that vision system. So the first is going to be lighting. Second is lenses. The third is going to be your image sensors, so your camera, your frame grabbers, and other different types of hardware. Next is going to be a processor that's going to actually be able to process that information. And then finally communication, right? So how is that vision system going to send that information? What is it going to do with it? So the first, lighting. So lighting is one of the most crucial aspects of machine vision. Failure to properly illuminate a target can result in the loss of information, productivity. A lighting technique involves a lighting source and its placement with respect to the target and the camera. Some examples of lighting sources are backlit lighting, bar lighting, dome, and ring lighting as well for manufacturing sense, and say lab applications. But in some cases, CCTV, ambient light, the light that you're going to get in CCTV is from most likely the sun. And then in the dark, you're looking at IR illuminators, and all of these can help you give the best picture for the target. The next key component to any vision system is going to be the lenses. So the lenses captures and it delivers the image to the camera sensor, plain and simple. The lenses will vary in optical quality and price. The lens used determines the quality and resolution of the captured image. So deciding on the right lens for a machine vision application, it requires reviewing required aspects. So doing some math, considering how the lens will integrate with the camera setup. And we'll dive in a little bit more into this. And one of the things I'd like to bring up is we actually have a calculator that can do a lot of this stuff on our global website. So we can give you that information if you guys need that in the future. The next kind of key component is going to be the image sensor and some other components as a frame grabber, basically. So part of the hardware that works together to process the image from the camera and convert it into a digital format, the image sensors are going to convert that light into electrical signals as pixels. The frame grabber, that's an electronic device that captures individual or digital still frames from an analog video signal and digital video stream. The next key component to any kind of vision system is going to be the vision processor. So processing is the mechanism for extracting information from a digital image, and it may take place externally in a PC-based system or internally in a standalone vision system. Processing is performed by software, and it consists of several steps. So first, an image is acquired from the sensor. In some cases, pre-processing may be required to optimize the image and ensure that all the necessary features stand out. Next, the software locates the specific features and they run measurements. It compares these specifics and these specifications. Finally, a decision is made and the results are communicated. So while many physical components of machine vision, such as lighting, offer comparable specifications, the vision system algorithms set them apart and should top the list of key components to evaluate when comparing solutions. So depending on the specific system or application, vision software configures camera parameters, makes the pass-fail decision, communication with the command center or a factory floor in some cases for manufacturing base, and supports HMI development. So all these are key components in that that vision processors. The next key component is that communication aspect, right? So since vision systems often use a variety of off-the-shelf components, these items must coordinate and connect to other machine elements quickly and easily. So typically this is done by either a discrete I/O signal or data sent over a serial connection to a device that is logging information and using it. So discrete I/O points may be connected to PLCs, programmable logic controllers, which will be use that information to control a work cell or an indicator, such as a stack light, or directly to a solenoid or something like that might trigger a rejection mechanism. And then that data communication by serial connection can be in the form of conventional RS-232, so serial outputs, or even Ethernet. So some systems employ a high level industrial protocol like Ethernet IP, which may be connected to a device like a monitor or some kind of HMI or operator interface, and that provides an operator interface specific to the application for conventional processing, monitoring, and controlling. So all that communication system kind of works together and helps that vision system as well. So on the next slide, so those are some of the key components in a vision system. The next slide, we're going to talk about some industries, right? So the first one is kind of my industry, that manufacturing industry. So machine visions for manufacturing, they ensure compliance through precision inspections, consistency and repeatability of measurements, and real-time feedback. So these systems also log and capture data, which ensures better product tracking and allows for subsequent analysis. So automating product inspection and analysis has improved quality control, accuracy, consistency, speed, leading to enhanced production efficiency and reduced cost. So early issue detection reduces that risk of product recalls. The next industry is the healthcare industry. So machine vision inspection technologies is used to inspect, analyze medical images to identify abnormalities. It uses AI algorithms and deep learning techniques to process images. Also detects and identify potential areas of concern. Pharma vision inspection can verify codes, determine packaging integrity, and provide product traceability within all areas of that supply chain. The next industry is transportation. So machine vision uses cameras, sensors to capture images and data, which are then analyzed by that powerful AI algorithms to detect defects, damage, weather, maybe wear and tear as well. This technology helps transportation companies identify and fix issues quickly, ensuring the safety and reliability of that equipment. So it has transformed this industry, whether it be license plate readers or just straight up identifying different types of vehicles, stuff like that for law enforcement, and also for facilities like TxDOT as well. Agriculture is the next industry. So machine vision inspection can improve crop yields. So detecting and reducing pests, diagnosing diseases using multispectral imaging. So we've seen some SWIR start to be used in this area, or shortwave infrared, and a lot of that can look at individual plants. It can look at whether it needs a watering. So if you need to water certain areas, if you need to say apply fertilizer to certain areas, it can help you get a better overlook of your crops using that SWIR. It's actually a growing trend, and that industry is very it has a lot of potential, especially for that SWIR as well. Next, we're going to talk about some future impacts of that machine vision, right? So we have the machine vision, we have AI, all of that is bringing a huge influence into the industry, right? And so it's applying to multiple different types of industries, whether it be a manufacturing with a smart learning and AI type applications as well, or it's the medical field. So it's brought in this huge kind of transformation in that field of automated inspections as well. So some of these areas that we kind of want to key on when talking about sustainability and energy efficiency, the use of robotics and AI, it can also lead to significant energy savings. For example, in manufacturing facilities, robots can optimize production processes by reducing the need for human labor, thereby minimizing energy consumption and emissions. In logistics, autonomous vehicles can optimize delivery routes and reduce fuel consumption and emissions. When looking at, say, quality control, with the help of high-speed machine vision, robots can quickly and accurately detect and analyze visual data, such as object recognition and tracking, barcode scanning, quality inspection. This has enabled organizations to streamline their inspection processes and carry out quality checks with unprecedented speed and precision, leading to improved productivity and cost savings. The next kind of future impact is that economic savings and economic benefits. So that benefit comes from increased efficiency and less waste, period. Next, we're going to be talking about choosing the right lens and the importance of choosing that right lens. So here we have basically a quote that says, your inspection system is only as good as your machine vision, right? So the first thing that we want to do, we have a checklist here, and these are some of the things that I kind of go through when I'm looking for a lens and trying to choose a lens. And so one of the first areas I'm looking at is the image sensor, right? So what image sensor am I using? Is it a Sony? Is it a G-Pixel? What kind of camera do I have for my application? Maybe I don't know the image sensor, I know the camera. Well, go into the camera, look at the specs, figure out what kind of image sensor you have. Because a lot of lens manufacturers like Computar, we will list and branch our lenses to the image sensor. So that's kind of the main important one. Second one is, you know, with that image sensor, what image size does it have, right? So I have an IMX 183 or IMX 990, right? What kind of image sensor size is that? Is that a 2/3? Is it a 1 inch, a 1.1 inch, a 1/1.1 inch? There's a lot of different measurements out there. So that's another thing to kind of take into effect what kind of camera and what kind of image size do I need? If I get a lens that has a smaller, that's smaller than my camera, I'm going to get some type of vignetting effect, right? So those are some things to look at. So what kind of distortions do I get when I'm not choosing the right size? And then when I'm looking at the lens, based on the application, do I want a standard lens? Do I want to measure? Am I doing some type of measurement, maybe in a manufacturing sense? Do I need a macro lens that's going to be more accurate for measurement? Do I want remote adjustments, right? Do I need a different spectrum? Do I need SWIR? So those are some of the things that you need to think about with your application. You know, do I want a fixed focal or do I want a varifocal? And that kind of brings me to the next point, which is your focal length, right? So what type of focal length do I need? Well, sometimes I don't know. Sometimes I know how far my object is, what my working distance is, and sometimes I know what my required field of view might be. And so this is the calculation part, and we have a calculator online on our Computar-Global website, and that calculator, you can put in your image sensor, you could put in your working distance and your required FOV, and it'll tell you what the exact focal length that you need to achieve those numbers. So that's the math part. And then the next is, okay, what type of resolution is my camera, right? Going back to the image sensor, what's the pixel size, right? Is it an 8K camera? Do I need 45 megapixel or do I only need 2, right? Because you know, pricing is going to vary on lenses based on those types of specs. And then the last two are kind of grouped together, right? What is my environment? Is it a CCTV type application? Is it for traffic or transportation where I'm going to be needing to look at license plates? You know, looking at certain applications, you know, how fast do I need a frame? You know, so looking at frames per second for some certain cameras and environment lighting, all that stuff kind of plays into effect. And once you kind of check those off, that'll narrow you down into certain avenues, to certain lens series that would help you for your application. So let's get into some of those certain series. So this first one here is our Lens Connect series. This is one of our most featured products. It is a remote controlled lens, and it has a USB interface. So as you can see, I've got several different models here. We've got multiple different lineups. We have a fixed version. So if you need an 8mm, a 12mm, or 16mm, all of those, as you see right there, we have those in fixed all the way up to 75mm. And then in the varifocal side, we have 16 to 96mm. We've got a 9 to 50 and a 4 to 10. And we've got a couple other Lens Connect series that are in development right now as we speak. We're getting some proof of concept samples sent out. And if you have, or if you have any other questions, or maybe you have an application you'd like to see a little bit more into this, let us know. But the key points for this guy is it's got a floating fixed design, so ultra high resolution. These are suitable for large format sensors. So again, here's my image sensor, IMX 183. Plug and play, easy for deployment. The software is free with this guy. You go on our website and download the software. We have SDKs for you guys. If you want to program this into your own system, software is very easy and we can give you source codes. But this guy is connected with a USB and it has 3 stepper motors inside the lens. And the stepper motor is going to control the focus, the iris, and the zoom. And you're going to use and do all of that from the software all remotely. And then with the USB there, you know, you can go up to 5 meters. So whatever type of application you might have, you can get back and get that distance as well. This is really great for robot type applications. Maybe you have a robot arm, or you have an area that changes, you know, the focal length changes and you want to zoom in, zoom out. Maybe you have certain areas that you want to plug these into. You can do that with this with this lens. Or you have a high area, maybe an area that's up high, and you don't want to have to keep walking up a ladder and adjusting the lens. You can do it on the fly, adjust the lens on the fly while looking at the feedback. So that's really great option for this guy. The next option is our VisSphere, which is our hyperspectral or multispectral lens series. So this is full sphere and visible spectrum, 400 nanometers to 1700. What's awesome about this model, this hyperspectral model, is if you're shifting between the two, there's no focus shift, right? So you don't have to go back and refocus with this. So visible and sphere sensor, high resolution. This is probably has the highest resolution and lowest distortion on the market right now. We can send you MTF graphs to kind of prove that, but this lens really outperforms everything. It's compatible with the latest InGaAs sensor, camera sensor, so the IMX992 and IMX993, and the pixel size is 3.4 microns. So really great, powerful lens here. The next powerful lens here is this MPT series, this 45 megapixel, 1.4-inch format. So this is for the larger image sensor formats, 45 megapixel. So suited for the IMX350, the 2.7 micron pixel size, C-mounted, it's compact, it's lightweight, ultra low distortion. And then we have those several different model focal lengths. We also, kind of a side note, we are coming out with a ruggedized version of this guy. So if you have areas that have high vibration, if you have areas that have high shock, this is going to be the ruggedized version is going to be an avenue for you guys to look at. This series is our newest series. It's the MPX series. So it is a ruggedized machine vision lens. So it's anti-vibration, shock resistant design, 16 megapixel for that harsh environments, inspection environments. Maybe you got a steel mill or something where you've got a lathe moving or some type of press moving and causing a lot of vibration. This is something that's going to be able to withstand all that, hold up, and kind of last longer. It supports high resolution lenses, so up to 2 microns or less in pixel size. The floating mechanism enables high performance, so close up and to long distance as well. The focus rotation angle is 5 times wider for precise adjustments. And then we've also adopted this click type iris mechanism. So when you change the iris, you can actually hear it click and get you very precise settings for the iris. Ruggedized mechanical design minimizes the image aberration. So this guy is a beast, especially in that environmental sense and manufacturing environments. So 8 to up to 75 millimeter. And so on this section, we'd love to do a Q&A. So if you have any questions on any of these lenses, maybe you have an application that you want me to take a look at or kind of talk with me a little bit about, definitely shoot it in the chat right now, and we can kind of read some of these questions. And yeah, and we can kind of read off some of these if anyone has any questions.
What would be sorry, I just chose to to speak up instead of the chat. What would be probably the most ideal camera for inspection purposes as far as really small defects on a glass fiber? That's the product we use here, is glass fibers. And defects could be ranging from scratches to debris and such. So it doesn't need to be rugged, I don't think, but it just needs to be fine enough to pick up on defects. So what are your recommendations for that?
Yeah, I mean, that's a good question. There are a lot of different companies that are going to have, a standalone type vision system. There are a lot of different companies that could offer something that could do that specifically. There might be other avenues like micrometers, other different types of sensors that might be able to inspect a whole kind of area or a whole platform of glass, um, and actually see some of those kind of small scratches. As so maybe you look into laser micrometer type stuff, or camera. There are a lot of other different types of kind of lighting effects and algorithms that might be able to do that. So I mean, off the top of my head, there are a lot of good different companies. Omron's a good one that has a good camera system. They use some of our lenses as well. Another good one might be Keyence, is a good company, and I might be a little homer for them because I worked for them for 10 years. So those are other good companies that would use and have the type of processing, the algorithm, the software, the lighting, have it all together. So yeah, I'd look at Omron, look at Keyence, and then there's other times where you just build your own. You could get a Brasler camera. You could pick one of our machine vision lenses, the MPZ lens series, and it depends on lighting, stuff like that, and kind of the algorithm that you teach your system to look for, if that makes sense. So
Yeah, no, that's great. Thank you.
yeah.
Jonathan, we have one other question. Do you have a lens that can be used in a drone?
Yeah, so the MPX series that I just mentioned, the ruggedized one. I mean, for drone type applications, it really depends. Is it the smaller drones that you're running around, or is it big military type drones? I've seen big drones that would say cover and look at, say, forest fires, and some of the type of lenses that they use was the MPT series. So something that's got a high megapixel, so that 45 megapixel lens that I kind of just showed, that guy's was actually used for that type of application to kind of map out a forest fire. And so for big drones, but then also for smaller drones, we do have some S mount type lenses. We're coming out with a new series of S mounts. So it's a new series that's not on the website yet. And then we also have, like I said, that the MPT, the MPX, that the any kind of vibration, sometimes a lot of high vibration over time can damage your vision system, can damage the lens. That MPX kind of helps mitigate that. So. Any other questions?
I don't see any other.
Okay, no problem. So kind of next,
Yeah.
I don't know if you guys or anyone here in the chat is going to be in Chicago a few weeks, but we will be at the Automate show. I would love for you guys to kind of stop by and see me at the booth 3342. So we'll be at the McCormick Center in Chicago. So come check us out at the Automate show.
There's a link on our events page for free passes to the exhibit exhibition hall.
Awesome. Yeah. So take advantage. If you guys live in Chicago or near, there you go. And I just wanted to thank you guys. This is my contact info. So if you guys have any other additional questions, maybe you want to see some pricing, you have an application you want to talk through, let me know. Give me a phone call or shoot me an email right there.
I just wanted to mention real quick too that we will be sending out an thank you email with a link to the tool that you mentioned, the FOV calculator, And there will be a link to the recording of this webinar as well.
Perfect. Thank
Okay.
you, Dina.
Thank you very much. Thanks, everyone.
All right. Thank you, guys. Have a great day.